Have you ever wondered how some AI applications just get you? Like, they understand what you really mean way beyond simple keywords? Well, the secret is this really powerful technology that's completely changing search as we know it. So let's pull back the curtain on vector databases and embeddings. They are the real engines powering the smartest AI you're using every single day.
Okay, think about a simple search for the word apple. A traditional keyword search, well, it might just give you a bunch of results about the fruit. But what if you actually meant the tech company? And boom, right there, that's the problem. Keyword search is just matching letters, but semantic search, the kind that's powered by vectors, it understands meaning, and getting that right is what makes modern AI feel so smart. So in this explainer, we're going to break it all down. First, we'll dive into why keyword search just isn't cutting it anymore. Then, we'll unpack the magic behind embeddings and the special vector databases that hold them. After that, we'll put it all together to see how semantic search actually works, and finally, we'll look at what this all means for the future of AI.
All right, first up, let's really dig into this core problem. I mean, we're living in an age of incredibly sophisticated AI, and we're surrounded by all this unstructured data, texts, images, audio. We need systems that can search based on conceptual similarity, not just on exact word matches.
And this isn't some niche little problem. We are talking about a massive, exploding market. The demand for this tech is just blowing up, projected to hit $4 billion by 2025. That's an incredible 50% growth year over year, which tells you that understanding this stuff is no longer optional. It's absolutely essential.
And it's not just a wild forecast. The industry experts are seeing this shift happen right now. Gartner is predicting that in just a couple of years, 3/4 of all enterprises are going to rely on vector databases for their AI workloads. The takeaway here is crystal clear. This is fast becoming a fundamental piece of the modern tech stack.
So how does AI actually solve this context problem? Well, the journey starts with this foundational concept called embeddings. This is how we literally teach machines to grasp the real meaning behind our words and all our data.
An embedding is, at its core, just a list of numbers, a vector, that acts like a coordinate for meaning. AI models, like BERT or the ones from OpenAI, take a piece of data, whether it's text, an image, or even an audio clip, and they translate it into this dense numerical format. And the cool part is, things with similar meanings end up with very similar numbers.
And this is where it gets really cool. Because these concepts are now just numbers. You can do math with them. Take this famous example. If you take the vector for king, subtract the vector for man, and then add the vector for woman, the resulting vector is incredibly close to the one for queen. This just brilliantly shows that the system isn't just storing words, it's actually capturing the relationships between ideas.
Now, this idea isn't brand new. It started gaining serious traction with models like Word2Vec way back in 2013. But with the rise of way more powerful models like BERT and then multimodal systems like CLIP, which can understand both text and images, embeddings have become a cornerstone of pretty much every modern AI application out there.
Okay, so once you have all these powerful embeddings, you need a place to store them, and, more importantly, search through them. And you have to do it super fast. That's where vector databases come into play. Honestly, the best way to think about them is like a highly specialized library, one that's built not for books, but for meaning itself.
You see, a traditional database is perfect for finding exact matches in structured data, like, say, finding a user with a specific ID. But a vector database is fundamentally different. It's built from the ground up to handle unstructured data and do one core thing exceptionally well: find the most similar items to your query and do it almost instantly.
And the market is already full of some great options. You've got managed services like Pinecone, which is known for being super easy to use and scalable. Then there are powerful open-source solutions like Weaviate, which brings this whole idea of a semantic schema to the table, and Milvus, which is built for absolutely massive, high-throughput applications.
At their core, these databases really do three main things. First, you insert your vectors, usually with some metadata attached. Then you query them to find the k nearest neighbors, which is just a fancy way of saying the k most similar results. And crucially, you can perform hybrid searches, combining this awesome similarity search with traditional keyword filters for ultimate precision.
So now we have our two key ingredients. We've got embeddings that capture meaning, and we've got vector databases that can search for it. Now let's put them together and see the magic of semantic search in action. The whole process is actually elegantly simple. First, you take your raw data, your documents, your images, whatever, and you ingest it. Step 2, you use an AI model to turn each piece of data into a vector embedding. Third, you store and index all those vectors in your vector database. And finally, when a user makes a query, you embed their query too, and then you just ask the database to find the closest neighbors. That's it.
But modern systems often take this a step further with something called hybrid search. Just imagine searching for products that are similar to this red dress, but you only want to see ones that were added in the last month and are under $50. Hybrid search combines the power of vector similarity with the sharp, precise filtering of traditional databases, and that gives you the absolute best of both worlds.
Okay, so we see how it works, but what does all of this really mean for us? This isn't just some theoretical concept. It is having a huge real-world impact today, and it's already shaping what's coming next.
I mean, this technology is what powers the next generation of chatbots that can pull answers from huge knowledge bases using RAG. It's behind the recommendation engines that suggest products or movies you'll actually love. It's being used in fraud detection to spot unusual patterns, and even in biopharmaceutics to speed up drug discovery. The point is, you are likely using this technology every single day, maybe without even realizing it.
Of course, building these systems isn't totally straightforward and involves trade-offs. Engineers are in this constant balancing act between latency, which is how fast you get a response, recall, how accurate the results are, and throughput, how many queries you can handle at once. And fine-tuning these is the real key to creating a great user experience.
We've gone from simple keywords to searching by pure meaning. So what's next? As this whole field just keeps accelerating, are we heading towards ultra-secure, quantum-resistant databases? Or are we going to see tiny, powerful vector databases running directly on our phones and our IoT devices? Well, one thing is for sure. The future of how we find information will be driven by meaning.